It's Tuesday Talks with Birkeland. You just finished a test and they are graded and entered. Luckily, I have time to make a video here. I almost forgot. Thanks to Miss Carol for that quick reminder. I have Tuesday Talks. Tomorrow we're going to go just a tiny bit into the last section of Unit 5, but we are definitely going to do our SPAC testing practice on the computers. So I figured I'd go over a few things. If you watch this, you may feel a little less frustrated when you see some topics on our SPAC test. Here we have negative 5t is less than or equal to 15. Just a real quick reminder, these solve just like when you solve a linear equation, but you want to watch when you divide by a negative. So if I divide by negative 5 on both sides, that flips your gator, so you get t is greater than or equal to negative 3. And that's it. Little side note, if you ever want to say that, that means your t value is bigger than negative 3. You could be from negative 3 to infinity. That's your interval notation. Just a couple things we used to do in that first chapter. Another review topic, what is a function? Up at the top, they have pictures of the colorful functions there. Those are all functions. You've seen them before, but you maybe have talked about what makes something a function. For every x value, so if I would go in here, x is 4 on this green graph, y is a value of like negative 0.75. When I plug in 4, I don't get this value and another one. That would not be a function. So for every x value, it goes uniquely to only one y value. This x value cannot map to something else. That would not make it a function. They also talk about the vertical line test. If you ever drop a vertical line down your graph, you should only hit that line one time. So that's what makes it a function. So think about what isn't a function. One of these two is not a function. Let's look at which one. Every x in this category is mapped to one unique y. It might concern some of you that right here, this 2 is a y value for both negative 1 and 0. That's kind of like x squared though. When you plug in 2 to x squared, f of 2, you get 4. When you plug in f of negative 2, you also get 4. They can share the same y value. A parabola is definitely a function. They can share the same y value. It's just here's your concern. You can't take one x value and map to more than one y value. So this is your no function right there. A couple other examples here. You'd want to look for, see how this 3 right here, it says I want to be negative 6, and the same 3 says nope, I want to be 8, no, I want to be negative 10, no, I want to be 12. If you were going to graph that, right off the bat, you could see it doesn't work. 3 is at negative 6, positive 8, negative 10, and positive 12. It violates that vertical line test. So this would not be because he's trying to map to two different, that negative 2 is trying to map to two different y values. This one would be okay, even though they double up there. This one is because they're mapping to the same y value. And here we have this 1 is going to 0 and 1 is going to 1. Again, he cannot make up his mind, so it's going to both of those in a way. This one would be no. And there's just one more quick view. Again, anytime it passes the vertical line test, yes, yes, no, yes, no, no, yes, no. That's how you know it's a function. All right, simplifying. We kind of did these in our last test, but this takes you back to math 2. Here we could get x squared plus 6x plus 8. Remember, though, this is all being subtracted from when we square this. A common mistake is kids just put x squared plus 9. You would have to go x minus 3 times x minus 3. Don't forget that minus 6x. So there's my initial, subtract this, carry that negative through just like we mentioned on the test. X squared take away x squared is nothing. Negative 6 take away 6 is 0. And 9 take away 8 is 1. So that would be all you have left there. All right, another topic that you might see on SPAC or review is exponents. You have the power over the root. So your power would be the 3 and your root would be the 7. So we could rewrite this as x to the 3/7. Oh, just kidding, I did that wrong. X to the 3/7. This is another way to write that same radical. All right, and then finally, exponent simplifying. You would just take your number times the number, so you have negative 10. X is to the 3 and to the 2, so that'd be 5. Y to the 1, we don't see it there, but we could add it to the 7 and get 8. Little bit of power and exponent rules you can work in there. And finally, math 2. This is a coordinate in, say, like geometry or your math 2. What we did to x, they said you're going to do x plus 3. Well, think what that would do. That would shift it Okay, so which direction is it going to shift it? That's going to shift it to the right. So that would be a translate or a shift to the right 3. And then this negative y. If I was graphed at, let's say, this point right here and I had a 2, if I want if this was 2 and I want the negative of that, that's going to go down here now. It's a negative 2. So that would be a flip over the the x-axis. So we would say this is a reflection over the y-axis. Oh gosh, I'm kidding. I'm not starting over, sorry. This is not a reflection over the y-axis. A reflection over the x-axis. Because this would be the x-axis. So that's just kind of a little bit of a remembrance from Math 2, these transformations, this notation. Plussing and minusing moves it up and left and right or up and down here with a y, and the negative in front of it flips it over. This is flipping over the x-axis. If it was negative x, it would flip it over the y-axis. All right, that's all I have for today for Tuesday Talks. Hope you enjoyed it. It's kind of review from random things. Berkland out.